Okay, so if we see that word coefficient, okay, the coefficient, okay, what do we know about relevant to the coefficient?
Is it in front?
It's in front, but let's be a bit more kind of higher level thinking rather than it's in front. What else do you know? The knowledge that you have about the coefficient, how to calculate the coefficient, that kind of thing. Oh, I think you said you multiply it, but again, it's like, yeah, it's what the expansion, it's the number in front or whatever, but like I said, let's think a bit more about, we know it's the number in front. That number, we are told, is 135n. But what I'm asking you for is there's more to this binomial expansion to do with coefficient than just it's a number you multiply. What else do we know? Because if you're looking at that question in an exam and you need to go, I have no idea what they're talking about, where they go, well, you see the word coefficient and you have to think, well, what do I know? What can I write down?
Isn't it the value that we do know? Like we know that it's.
There are certain things. Go on.
Isn't it the funny thing in the brackets top and the bottom that means division?
Okay. Yeah. So I'd go with that. The coefficient would be the NR value. Yeah. Or that would be part of it. Yeah. Does that make sense to everyone?
So that's what the coefficient is?
Well, that would. Do you remember if we've got NR, that would be a number and something else. Yeah. All right. Two numbers depending on what the expansion is and which term. Now we can do that, we can convert that to a number, can't we? How can we do that? How can we convert this to a number? Using your calculator. Okay.
N apostrophe thing. I mean exclamation point.
It's not what
N factorial.
Yes.
Over,
N factorial.
over R factorial bracket N minus R close bracket factorial.
Okay. So we've got that as well.
Yeah, but you don't know what N or R is.
Okay,
so.
right. So at the moment we don't know N and R, but that doesn't mean we discount this stuff. Can we figure out N or R?
Aren't you meant to be finding N?
Yeah, so we're meant to find out. So that would suggest we can't find N until the end.
Don't we know that when it's going to be like 3?
Say that again.
Isn't N? No.
So this is question. N is something we don't know. We're being asked to find N because N is that N. Are you okay with that?
Yes.
This N here. Oh, wrong thing.
Is that the same N as the N?
That's the same N, isn't it? Are you happy with that? So this N, which is the value for the expansion, they've been nice, they called it N. That number here is what we use at the top there, no? So that's what we're being asked to find, which is quite nice because that's in my formula, no?
Yeah.
So that's nice. I've got a formula which has that N in it. The thing is, I've got an R.
Wait, is the 135N the same N?
So this as well will be all of this though, not just that N. Yeah. So, yeah. Is there any way of finding the R? So this is where I'm thinking, do you know, have you figured out, can you remember what, if N is this, R is this, or if I know what term I'm looking for?
Is R X?
R's not X. Think back to how if you know R, if you know N, how do you know what R is going to be? Think back to basics for the expansion.
Is it just which one it is?
Depends which one it is,
Like,
yeah.
Which, no, I mean like 1, 2, 3, so
So the N very much matters which level down the triangle, I think. Is that what you're talking about?
very last one.
You're talking about the R. Okay. R depends on, so n is always the same, isn't it, for every single one along a row of expansion, but R is the
Where it is in the expansion.
where it is in the expansion. Yeah? So R changes. It starts with n 0, doesn't it? So we've got, if I were to expand, so I might not put this in my working, the next bit, but if I would say my expansion would be n 0, then n 1, n 2, n 3, and so on, yeah?
Wait, so do we expand that, the 3x plus 1, until we get...
Well, we can't, can we? I know, I see what you mean, yeah. I could make guesses what n would be and expand it and see whether I end up with 135n. That would be one way of doing it. It would be a very, very long way, and you wouldn't get anywhere near the marks. You know, that question wouldn't be worth that many marks. There's got to be a better way. But you're right, we could have a guess at what n is. We don't need to. There's a better way of doing it. But do we see how we've got n0 all the way up to nn? Now we don't even know what that is, do we? Because this number depends on what n was, and we don't know that. We've got to find it. But is there any way of identifying the 1, 2, 3? Does this help me at all?
Square. We just use Pascal's triangle.
Well, Pascal's triangle that's what we're trying to find. We can't do Pascal's triangle until I know which row it is. But is there any way of using the x squared bit? So if I look at the expansion here.
Oh, it's gonna be x. It's gonna be n1. Wait. No. It's gonna be n0.
You're thinking, I can tell you're thinking it through. So, what we're looking for is, we know this is an x squared term. What that means is, in my expansion, after one of these coefficients, I'm going to have a x squared. Yeah? And I'm expanding this. So if I think about it, this first one would just be 3x to the power of
n.
Yeah?
So n is...
So the next one would be plus 3x to the power of
1n?
n minus 1, because we drop 1, but times 1 to the power of...
n. Is that a sequence? Wait, I remember this.
So this is what we've been working on, the binomial expansion stuff, yeah?
Why is there a point 1 right there?
It's a times.
Oh, it'd be 1 to the power
So,
of 1.
1 to the power of... No, what would it be? 1 to the power of 1, okay? Yeah? Plus, then it would be n over 2. Then it'd be 3x to the power of n minus 2 times 1 to the power of 2. Yeah? Then it would be n3, and it would be 3x to the power of n minus 3 times 1 to the power of 3. Yeah?
What are those dots?
Timeses. I'm going to put a times. Right, now, maybe we've got a better way of thinking about it if we think of it from the other direction. Because this isn't helping us, is it? I've got 3x to the power of n minus 3, but I don't know it. Alright? Do you remember the symmetry of these expansions? What about if I started at the other end? So instead of going that way, if I start the other end, Yeah.
How come it's not 3x plus 1? Any brackets?
Because that's the basics of binomial expansion. We did like day one is how you expand. Remember if it was a plus b to the power of 4, it's a to the power of 4 plus a cubed b plus a to the power of 2b and so on, yeah? And then these would be 4, 0, 4, 1, 4, 2 and so on, yeah? So we're using that knowledge that we had from a couple of weeks ago, and we're just kind of applying that now. You maybe need to go back and review your notes if you've forgotten all of that. Is everyone else following at this stage, or? Yeah. So remember, we're using that pattern that we noted very early on. That's the first thing we did. Remember that when we did this expansion, we ended up with numbers here, which was the Pascal's triangle. Right? So actually, I'm probably all of this. So remember we did that. We looked at Pascal's triangle. Those were the numbers. So we did an expansion. We noticed that it was 8. If it was to the 8, all of this stuff.
Mr. Claus, is that up on the website too?
This is the video. Yeah. I think. But the video actually is only this last bit. I think I sent you these notes anyway a while back, and it's all in your textbook. So the video, I think, was solving that one.
Can
So
you send the other ones then that weren't in the video?
well, I think I've already sent that whole document once, but I can resend it. So, but anyway, so we're using that stuff that we've worked on, and we're using this expansion now. Do you get what I mean about how it's not particularly helpful at the moment? Because I've got the n next to the x, and I don't want it like that, do I? So if I started at the other end, would that help? Do you know what I mean by that? So if I started, the final term would be nn, but it would be only the 1 to the power of n. Okay?
Okay.
Then the term before that would be n over
N minus 1.
n minus 1. Right, so I'm going to have to give myself a bit more space. So it would be n over n minus 1. Oh.
Is that following on from what you had above?
No, I'm starting at the other end and I'm coming backwards. Then it would be 3x to the power of, if I'm going back in reverse, times 1 to the power of n minus 1, and 3x to the power of 1. So does that help us now, because we're working backwards?
Wait, how come the n over n went to the n? It doesn't have 3x.
Because remember, that's 3x to the power of 0. Remember, the final term doesn't have it. Remember that? The term before that would be n over n minus 2, and then we get our 3x to the power of 2. That's nice, isn't it? We've now got it. Times 1 to the power of n minus 2.
So that's the 3x squared.
Now we've got our 3x squared. Yeah? Does that make sense? So we've kind of, rather than working that way, we've kind of come backwards instead. So we've started with the final term and we're working backwards. So we're working backwards to find the term in x squared, which is what we've got now. So I've got this x squared term, right? Which is what I've been looking for. Alright? Are you all with me at that stage?
So n over n to the 1n is only for the last term, or is that just one big thing?
That is the final term, isn't it? And we know what n over n is. Nn would be 1. Regardless of what n is, n would be 1. So that doesn't help us. N over n minus 1 is a value, but we don't know what that value is because it would be the same as n. We don't know what n is. Okay. But what we've got though now is at least we've got this term. So we've got a term, so using this, we've got n over n minus 2, which I'll ask you about in a minute, whether there's anything we can make it easier. Alright? And we've got 3x squared. I could simplify that to what?
9.
So times 9 times x squared. And then here's the bit, this is the knowledge, the easy bit of maths that you're expected to know, but you probably in a stressful situation, I don't know. What is 1 to the power of n minus 2?
1.
1. Hey? Why? Well, give me a power of 1 that's not 1. 1 to the power of 18 is 1. 1 to the power of anything is 1. So I know, regardless of what n is, so this little bit here, this piece of information, I know, and this is an important step because you have to get rid of it, that is equal to 1, regardless of what the power is, which is why it's nice. That 3x plus 1. If they made it 3x plus 2, the question would be all so different. So different. Because it's 3x plus 1, that's nice. So that means the whole 1 to the power of n minus 2, I don't need it there anymore, do I? It's all times, isn't it? In the expansion. I can see in your head you're doing what people that haven't quite grasped the difference between the initial brackets and the expansion. I see people putting pluses in because there's a plus in the first bracket and we don't have that. Remember when it's the a plus the b, it becomes a multiply, a times b, or a to the power of something. Okay.
Wait,
Yeah?
you know how we just said 1 to the power of n minus 2 is just 1?
Yeah.
Well, how do we know it's just 1 if we don't know what n is?
Because anything is
Like I said, 1 to the power of anything is always.
Oh, yes.
So it doesn't matter what n minus 2 is. It's,
Oh, yes.
Yeah, I can make it negative or a fraction or anything, yeah? It's always going to be 1.
It has to do with the, like, not...
Like I said, if that was a times 2 to the power of n minus 2,
Yes.
that's different, isn't it? Yeah.
Okay, I got it.
Yes, question.
So the first one where it's like n over 0 times 3x to the power of n goes to the last one where it's n over n.
So, if I was going to do the entire expansion, right? Remember, I start at the left-hand end and I start working out all the terms. Trouble is, I don't know all the terms because I don't know what n is. There's an infinite number of terms. Alright? So I can keep going. If I make n 1,000,000, then this would go on for 1,000,001 terms. If I make n 6, it'd go on for 7 terms. But I don't know. So I basically was going along in that direction, starting with the left-hand end and working like we have done. Alright? But then I looked at it and I noticed that, well, I need x squared, but on all my x's I've got an n, and I don't want an n. So I had to rethink my approach. So instead of working that way, from left to right, I started at the opposite end, the right-hand end, and I worked backwards. So I started with n over n, alright, because I know that's what it's going to be. And instead of doing n minus 1 that way, I'm doing it the other way, so I'm sort of applying my algebra in the opposite direction. Yeah?
So the second.
So this
one-
doesn't carry on all the way to there. It would do, but I've started again. I basically went, stop there, right? I'm stopping because it's not helping me. I've got n's with the x's. So I start at the final term, that's what I said, start at the final term and work backwards instead. And by doing that, I got the n's on the ones instead of, because here, look, it was 1 cubed, 1 squared, 1 to the power of 1. But by starting from the other end, I could think of it slightly differently and put the n's on the ones instead. And then the x's get the numbers. Now, they're never going to meet in the middle because I don't know where the middle is going to be. I don't know how many terms there are. So I can't keep going until I get to the middle. All I did was I went as far as I needed to do to see the 3x squared.
And how did you know what that was the final term?
Because when we do an expansion, going all the way back to these basics, look, the final term is, if it's to the power of 9, it's 9, and it's a to the power of 0, so that's basically nothing, it's 1, and then it's b to the power of 9, so b to the power of 9. Yeah? So I'm going back to those basics, which we... So here, look, the first term of an expansion of 8 is the a to the power of 8. The final term is the b to the power of 8. With no, yeah? So I've just used that information here to know that, but if I start that way, it's 3x to the power of n. But if I start from the other end, it's 1 to the power of n. So I'm working the other opposite way. Okay. So we've got this at the moment. Now I am told at the beginning of my question that the coefficient of the term x squared is 135n. So this is where I can put this in. So now, this is my term. Are you happy with that? What's the coefficient at the moment?
9.
Not just 9, but
135.
all of this, yeah? All of that is the coefficient. Yeah? Because remember, what's in the brackets gets turned into a number, either using your calculator or using the formula. So what I know then is that is going to equal 135n times x squared. So the two grey bits are equivalent. So now that kind of gives me information I need to find n. Does that make sense at the moment? Yeah? Now there are lots of things I could do at the moment. There are lots of ways to do this. But potentially what you might spot is that, well, is there anything you would do right now to make it slightly simpler maybe? Is there anything like on the left hand side that you know that you could kind of get rid of to simplify things?
X squared.
Well, the x squared, okay, so we don't need the x squared, do we? That's just, alright, so now I've got n minus 2 times 9 is equal to 135n. Anything else I could do? Get rid of? Make it simpler?
I thought we don't get rid of things, we multiply.
No, we don't move things. We do get rid of things by doing what? What can we get rid of to simplify? Divide it by 9. Let's divide this by 9 to get rid of that. So that leaves me with n over n minus 2 is equal to, you tell me, 135 divided by 9. Use your calculator if you like. 12. What is it?
15.
15.
Yeah.
So 15n. Right. So we've got it as simple as we can. We've now got those brackets. We've got to do something about them now. I've got it down to 15n. Right, I'm simplifying at this stage. I'm almost there. There's one thing I want to do that makes the brackets easier to deal with.
Times the n.
We can't times it. Remember that n over n minus 2 is not just a set of numbers, it's notation. It's not numbers you can just multiply by and whatever. Right? This here will be replaced by a number. But we've got to figure out what that number is. How are we going to do that? Well, these brackets, remember what we said? NR is n factorial over r factorial n minus r factorial. Trouble is we don't have an r at the moment. We have an n minus 2. I could put that in place of r and I could solve it that way. That'd be no problem. Well, it'd be hard, but it's not something that's impossible. Is there anything we could do though? Can I get rid of the n over n minus 2? Could I have it n over something else? By any chance? Anything you know about these coefficients that enables me to not change its value but make it simpler?
Add the 2.
It's not to do with adding or subtracting anything. It's a piece of knowledge you have. No, not that bit at the moment. Think about something we've said about Pascal's triangle, coefficients. What do we know about what's really useful about Pascal's triangle and the coefficients?
If they add up, they're the same. On the outsides?
Like, it's a pattern, so it's like what's on one side is on the other side.
Yes, it's called.
Palindrome.
Really? I don't know. That's an English word, isn't it? I don't know about that. Symmetries. No?
Yeah.
Symmetry. So, as Courtney said, actually, if I've got n minus 2, and n minus 2 is on this side, haven't I got one that's the same value but on the other end? Because of the symmetry? We've just got to figure out which one it is. So, it's not the first one from the right hand end, it's the third one from the right hand end. Therefore, it's got the same value as the third one from the other end, which is
2.
n over 2.
So R is 2.
So can we replace this with n over 2 is 15n? Because we're saying that n over n minus 2 is
So
the
n is
same
4?
thing as n over 2.
So N is 4?
No.
But that N minus 2 is not the same as the N, and the N minus 2 is not the same as the N above it?
No, because like you said, this is NR, sorry, NR, and N and R is not, R doesn't give you N, R is where you are along the expansion. Alright?
But how are you supposed to show that? Because they wouldn't they
You don't have to show that, it's a piece of knowledge you're expected to apply. Yeah? So for instance, you could, like I said, you could do that and put it into here, no problem. But actually it's going to be easier, instead of n minus 2, to just write 2. It's that piece of knowledge that they are looking for you to replace and use the fact that one thing is equal to another thing. It's used all through your maths. If one thing is equal to another thing and you want to replace it, that's fine. Alright? Doesn't matter what it looks like, it's about a value. And I know that n minus 2 has exactly the same value as n2. Right? Regardless of what n is. Alright? So if n was 15 over n minus 2 and 15 over 2 is the same value. Alright? But now that makes it easier for us to work with. So I've got this, and I've got this. So now I've got something a little bit easier to work with. It's still not straightforward necessarily, but it's a bit easier to work with. So what I'm going to do is I'm going to put anything I know into there now. So what was it again? It was n factorial. Do I know n? No, so that's got to stay over, is it r factorial? Do I know r now? So I've got 2 factorial, and I've got n minus 2 factorial. Okay. Now, I know that that's equal to 15n. But is there any way of simplifying this first? Well, what does n factorial mean? This is the jump. This is the thing that you're probably going to go, all right, okay. What does n factorial mean? What? Everything up until 1, yeah? But if n was 5, for instance, so if it was 5 factorial, how would you write 5 factorial expanded? Okay, 5 times 4 times 3 times 2 times 1. So n factorial would be n times what? Good. N minus 1 times n minus 2 times n minus 3 all the way up to n minus n. But it goes on for infinity until I know what n is, yeah? Right, that might make you think, well, what do I do now? But let's look at the bottom then. See whether that helps us. So, 2 factorial, that's a nice one. It's just what?
2 times 1.
Just 2. So you just put 2. Alright? Yeah. 2 times 1, 2. Yeah. What is n minus 2 factorial then? So it's going to be n minus 2 times n minus 3 times n minus 4 and so on.
Oh, you can cancel out the...
Yeah, so even though this goes on forever, it's like that well, I was doing another class about, do you remember how to convert recurring decimals to fractions? The top and the bottom, even though it goes on forever, you know they're matched up. So I know I can cross out n minus 2 with n minus 2. I can cross out n minus 3 with n minus 3. Can I cross out the n minus 4?
Yeah.
Yeah, that's gone because it would be there. And is everything basically crossed out up to n? Yeah? So basically I'm now only left with n times n minus 1 all over 2. Yes?
For n minus 2, why don't you just do it by n minus 1 and that's it? Because don't you have to go down to 1 instead of up?
No, remember you take away each time. So if I start with n minus 2, I've got to take 1 away. So it doesn't become minus 1, I've got to take another 1 off, so it becomes minus 3. Then the next one's minus 4 and so on. Yeah? So actually all of this gets simplified to n times n minus 1 over 2. So that it looked really complicated, we're actually that bit now. So what can I say? Now this bit is equal to this bit, no? Okay. Let me know if I'm going too fast. But there is a video, you can watch it again afterwards. So I'm going to rewrite it now as n times n minus 1 over 2 is equal to 15n.
If we, for the 2 factorial,
Yeah.
wouldn't it be 2, 3? Oh, never mind.
Because it doesn't go up, does it? It goes down.
It goes down.
So 2 factorial is just 2 times 1. Yeah, so it would have been 2 times 1, but I didn't bother with the times 1 because times 1 is just times 1.
Yeah.
Yeah.
And it never goes down to 0. It just goes.
Yeah, because if you did times 0, every factorial would be 0. Yeah. Okay. So, is there anyone at this stage thinks, yeah, no problem, do that? What do we do now? Let's get rid of stuff. What can I get rid of?
2.
I could multiply by 2, so let's multiply by 2. It gives me n times n minus 1 is equal to 30n.
I'm gonna grab 2 and yeah, I'm gonna just then that's bad.
No, questions are good. Not asking the question means you never know the answer. So what was your question?
Aren't you times this by 2?
I am, yeah. But this is where, by undoing stuff rather than moving stuff, it makes more sense. Because if I've got n times n minus 1, all divided by 2, if I times it by 2, I just get rid of this divide by 2, no? I don't. Okay, well now on this side, I've got 15 n's. If I double that, I have 30 n's. Yeah? Alright, what would you do at this stage? Good, I'm glad you didn't say multiply out the brackets. Because if I just divide by n on both sides, I get rid of that n and I get rid of this n, and I'm left with n minus 1 is 30.
Would it be wrong to expand it?
If you expanded it, you'd end up with n squared minus n is 30n. What would you do then?
I would add that n. I mean subtract.
So you'd end up with n squared minus 30n minus n is 0. So that would be n squared minus 31n is 0.
Yeah.
Yeah, you can do that. It's fine. But you'd have to go further. What would you do now?
Factorize it?
Yeah, so you'd factorise it back to n times n minus 31 is 0. So let's just leave it factorised. Yeah?
Yeah.
So at this stage we end up with n is 31. So our expansion was to the power of 31.
Mine is very neat.
Okay. Now, that's a challenging question, no?
Yes.
Worth lots of marks.
Like 20.
No, probably 7, 8 marks. Yeah. Can I just get you to, let's have a look while we're still recording. If we go back to the beginning, alright, can you think of, is there any point at which we would say, okay, can we go back? I would like you to review what we've just written. At what points in this question have we used just a piece of knowledge that's not necessarily something that's working out, it's just a fact you have to know that either makes it possible or easier.
Yeah.
So the symmetry thing, so we would go at this point here, wasn't it? So maybe you need to highlight that point and just say, yeah, this was a point at which you needed to have that information. You could still do it, no? It would still be possible. Because instead of the r being 2, you would have had an n minus 2 instead, and you'd have ended up with the same thing. Alright? is there anything further up where
The working backwards.
the working backwards thing, that was a kind of jump in your, well, again, it was like, if you didn't think to go backwards or have some way of doing it, an understanding level. So just for me, just to let you know what I would have done, and you will do, at this stage here, right, let me talk you through. When it said to me, in the question, we've got 3x plus 1 to the power of n, and I'm asked for an x squared term. Because I understand fully, I hope, right, what I thought was this. Well, that power, so I know I'm going to have a 3x squared, okay? I went straight to that point, and I know that here it's going to be n, and this number here, well, it's either going to be, so this would be n minus 2 because they have to add up to n. Now it can either be that one, but because of the symmetry, it could also be that one. So I actually jumped straight to that point. All right. You know, when your understanding's there, but you can see where it came from. But I just went, well, if I want x squared, I know there's no power on the x inside the brackets, so I know that that has to be a 2. Therefore, this is whatever n is minus the 2, because they have to add together. And then because that's a 1, that's all just not worth considering, or it doesn't need to be considered. So you can actually jump straight to this point here. I hope that works. All right. Yeah. So you can go kind of straight to that without all of that other stuff that we did. So that would make it a much quicker process. But you have to be there with your understanding before you can do that, don't you? All right. And then we still have to use the formula, that kind of thing. All right. Did you remember, do you get what I was talking about when I said to you, it says in the question, the coefficient automatically means in a question like this, a problem solving question, you're going to be using this formula. That's a way of forcing you to solve and use that formula. Otherwise you can just use your calculator. So there's a tip for exams. Use what they say. If it says the coefficient in the question and it's a problem solving question with n's and things, you're going to have to use the formula. Alright? You're not going to be able to use your calculator in this kind of situation. You're going to have to use the formula. So certain things like that. Alright? Right. So that, like I said, a challenging question. Definitely a challenging question. So what you can do now, let's go back a few steps. So in your textbook, do you remember what page it is?
Page 185.
185, is it?
That was 187.
I think we're at the point. Now you we're at this stage now of, so if you have a look at, from page 188, exercise 6.0, those questions now build up until you get to the exam style questions. I know, so that they can know what we're doing. Alright, so page 188, exercise 6.0, through to the review exercise, and there's quite a bit there, and you need to get to the harder ones. Alright, so you've just done a challenging one. If you understand that, then you'll be doing one.
Mr. Potts, can I just watch your video from the last